There are 7 lexical tones in Taiwanese. When tones come together in an utterance, the surface tone value may change. This is called tone Sandhi. There are at least 7 tone Sandhi rules that form a chain-shifted relationship. The solid line here represented the more frequently observed tone Sandhi rule, while the dotted line here represents the less frequently observed and dialect-specific tone Sandhi rules. Here are the pitch contours of the Sandhi tones in the left and the bass tones on the right. The 7 lexical tones are gun, 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 good, good. Within a tone Sandhi group, the final syllable carries canonical phonemic tone, which is also called bass tone. Bass tones are also known as juncture or citation tones. Here we will refer to the tone in tone Sandhi group final position as bass tone. The non-final syllable carries Sandhi tones according to the Sandhi rules. For example, the syllable cai in stewed cabbage is produced as cai in cabbage stew. So lo bei cai lo. The rule determines the alternation between Sandhi and bass tones in tone Sandhi group domains remain unclear for years. Even now, we are not sure what factors determine the alternation between Sandhi and bass tone. Previous morpho-syntactical study debated on whether it is the syntactical function or the syntactical structure that is determining the tone Sandhi group domain. From a syntactic functional perspective, an XP domain that functions as an argument corresponds to the tone Sandhi group domain. However, from a syntactic structure point of view, the tone Sandhi group domain corresponds to the maximal syntactic projection that is not lexically governed. Previous morpho-syntactical study claimed that tone Sandhi group domain corresponded to XP domain and found that only bass tones are produced before modification marker A. For example, in the word beach house here, the morpheme for sure B is produced with a bass tone before modification marker A. These morpho-syntactic studies claims were not validated by children's spontaneous speech corpus. It was found that children's tone Sandhi group domain can be smaller than a XP, or it can span across several XPs. In other words, in children's production, there could be several XP produced without bass tone. However, it is unclear whether this discrepancy between syntactical series and children's spontaneous corpus data is due to the limitation of morpho-syntactic series or the underdevelopment of children's production. This study intends to explore the Sandhi and bass tone alternation with adult spontaneous speech. Aside from morpho-syntactic approaches, phoneticians compare the VOT closure duration peak lingual contact from electropalatalography data in syllable, word, intermediate phrase, intonation phrase, initial positions across 4 languages. And they discovered that the tone Sandhi group domain is not a strict layer under the intonation phrase domain. So it is likely that tone Sandhi group is not a level of prosodic under prosodic hierarchy. Taiwanese Min Toby propose that tone Sandhi group is a level of prosodic break, and the production of base tone can be affected by pragmatic final particles or the modification marker A. To explore the first question regarding the morpho-syntactic impacts on Sandhi and base tone alternation, we will compare the Sandhi to base tone ratios before modification marker and final particles. To explore the prosodic effects on Sandhi and base tone alternation, the study compares the number of Sandhi and base tones in syllable, word, intermediate phrase, intonation phrase, final positions. We also use data-driven models to investigate the ranking of sociolinguistic factors, morpho-syntactic factors, and prosodic factors on Sandhi and base tone alternation. The sociolinguistic factor included age, gender, and dialect region. The morpho-syntactic factor included syntactic elements such as modification marker and final particle. The prosodic elements included prosodic boundaries, and the lexical factors include the percentage of Sandhi and base tone produced for each morpheme. We recorded 40 speakers from 5 dialect regions. Within each dialect region, there were 2 males and 2 females above 40 years of age, and another 2 males and 2 females under 30 years of age. Speaker produced 30 minutes of elicited spontaneous speech by answering questions regarding their hometown, hobbies, professions. However, they can talk about any related topics they prefer. The data produced was transcribed in 10 tiers, which include the orthography tier, the word tier with stem simple, the underlying tone tier, the surface tone tier, the syllable tier, and the segment tier. And there's also a linguistic tier tagging, code switching, borrow words, or syllable contraction. And there's a miscellaneous tier tagging things such as laughter, hesitation, or cough. There's also a break tier that tags the prosodic boundary after each syllable. We use logistic mixed effect regression models to explore the effect of morpho-syntactic elements and prosodic hierarchy and the sociolinguistic factors. And decision tree model was used to rank those factors we just mentioned. And so here are the results of base tone production before modification markers and final particles. On the y-axis are the number of base tone. On the x-axis are the number of Sandhi tone. Each field circle stands for the number of Sandhi and base tone produced by each speaker before modification marker, and the triangle stands for the each speaker's production of Sandhi and base tone before final particles. As we can see from here that there were more base tones than Sandhi tones before both modification marker and final particles. In other words, the syntactical series predicted the tendency of base tone production before modification markers. Here are the results on the prosodic influences. On the y-axis are the number of Sandhi, base, and neutral tone. Neutral tone are toneless and does not undergo tone Sandhi rules. And on the y-axis, on the x-axis are the type of breaks. As we can tell from here that there are more Sandhi tones than base tones before weak, low-level syllable and word boundary. However, before high-level, strong prosodic boundaries such as intermediate phrase, intonation phrase, there are more base tones than Sandhi tones. In other words, the number of base tone increased from low-level to high-level prosodic boundaries. Next, we explore the interaction between morpho-syntactic factors and prosodic factors. On the left are the base and Sandhi tones produced by each speaker before modification marker and final particles in word final position. On the right are the base tone and Sandhi tones produced before intermediate phrase boundary. As we can tell from these two graphs here, regardless of the prosodic position, there are more base tone than Sandhi tones produced before modification marker and final particles. The morpho-syntactic rule, which claims that only base tones are produced before modification marker, is not validated according to our results. However, they are indeed more base tone produced before modification marker. Although prosodically, there are more Sandhi tones in low-level prosodic final position than in high-level prosodic positions. Next, we will rank the importance of the morpho-syntactic, prosodic, and social-linguistic factor. We can tell from the results of the decision tree that the most dominating factor is the following element, which includes final particles, modification marker, and the intonation phrase boundaries. The percentage of base tone produced was the highest before intonation, phrase boundary, modification marker, or final particle. The next dominating factor is the prosodic boundary, which can be further divided into two branches, one for syllable for the high percentage of Sandhi tones produced before syllable boundary, and the other branch for Sandhi and base tone produced before word and IP boundary. The percentage of base tone increased from syllable final position to word final position, and there's even more significant increase in intermediate phrase final positions. And for this branch for tone 5/5 with vowel-only structure, there's a high percentage of Sandhi tones for predominantly the pronoun for he and she in IP intermediate phrase final and word final positions. So in other words, there's a lexical propensity effect on Sandhi and base tone alternation. So in sum, there's a morpho-syntactic effect and prosodic effect, as well as a lexical propensity effect on Sandhi and base tone alternation. Next, we will further analyze the lexical propensity effect. Here are two histograms of morphemes produced with Sandhi tones on the left and base tone on the right. As we can tell here, there are many morphemes that are produced with high percentage of Sandhi tones. However, there are very few morphemes were produced with high percentage of base tones. Again, this two histogram shows the effect of lexical propensity on Sandhi and base tone production. In sum, the application of tone Sandhi rule are not realized in a binary manner, but in a gradient manner. There are also rankings among the morpho-syntax, prosody, and lexical propensity factors. The discovery of lexical propensity is a surprise, and the speaker may assess the percentage of Sandhi and base tone production for each morpheme as exemplar stored in their minds. At the same time, they may apply the tone Sandhi rule according to morpho-syntactic and prosodic factor during their speech. Finally, I would like to thank National Science Council in Taiwan for supporting of the project. And my thanks to Sao Renlu for leading the Taiwan Min corpus transcription team. Thank you.